Section 12.4, measures of position. Percentiles. A data value x is in the nth percentile, p sub n, if approximately n% of the data is less than x. So if we talk about the 60th percentile, 60% of the data is less than 60. If we talk about the 5th percentile, 5% of the data is less than 5. N has to be between 0 and 99. The biggest use of percentiles is with growth charts in infants and babies and small children. Okay, everyone will tell you not to compare your child to someone else's, but each time you go to the doctor, they will tell you the percentile for your child's height and weight. Okay, so it is comparing the height and weight of your child to every other child that the data is recorded for. Percentiles. Example 1. The number of customers served by a restaurant on 40 consecutive days are listed right there, and they are in order for us from least to greatest. Find the 35th percentile. Please remember that the word percent means per 100. P sub 35. We don't have 100 data points. We only have 40. So there are 40 data points. To find the 35th percentile, we need to find 35% of 40. 0.35 times 40 equals 14. The 14th number in the list is 62. P sub 35 is 62. Find the 86th percentile. P sub 86. Again, there are 40 data points. 86% of 40, 0.86 times 40 is 34.4. Take the 35th number in the list, 72. The 86th percentile is 32. Deciles, percentiles per percent per 100. Deci means 10. A data value x is in the nth decile, d sub n, if approximately 0.10 times n% of the data is less than x. Breaking it into tenths, ladies and gentlemen, 10 sections. So from 0 up to 9, we're going to have 10 even sections. Decile 1 equals the 10th percentile. Decile 2 equals the 20th percentile. Decile 9 equals the 90th percentile. Example 2, find the 4th decile for the customer example. Data in example 1. The 4th decile, 0.10 times 4 times our number of customers. 0.10 because we're working with tenths for deciles. 4 because it's the 4th decile. Times our number of customers is 40. 16. Take the 17th data point in the list as the 14th decile. As the 4th decile. The 4th decile equals 64. Quartiles. A data value x is in the kth quartile, q sub k, if approximately 0.25 times k% of the data is less than x. We're talking quartiles. The word quarter is fourths, so we're splitting the data into 4 parts. The first quartile is the 25th percentile. The second quartile is the 50th percentile. The third quartile is the 75th percentile. Quartile 2 is the median. To find Q2, use the rules for computing the median. Q1 is the median of the lower half of the data. Quartile 3 is the median of the upper half of the data. Example 3, find the first, second, and third quartiles for the customer data in example 1. 40 data points. We'll start with the second quartile. The second quartile is the median. The middle two numbers are 65 and 66. The second quartile, or the median, is 65.5. Q1. Find the median of the lower half of the data. The middle two numbers of the lower half are 59 and 61. Q1 equals 60. That's Q1 equals 60. Q3. Find the median of the upper half of the data. The middle two numbers are 69 and 70. Q3 equals 69.5. Let's talk about box and whisker plots. It's a rectangular box positioned extending from Q1 to Q3 above a numerical scale or above a number line. The median of Q2 is indicated by a dotted line in the box above its value. Whiskers extend from Q1 to the minimum data value and from Q3 to the maximum data value. Example 4, draw a box and whisker plot for the customer data in example 1. We already found our Q1, Q2, and Q3. You can see our vertical line here for Q1, Q3, and Q2 is right there in the middle, the median. Not the middle of the box, but the median of the numbers. From Q1 down to the lowest value of 46, and from Q3 to the largest value of 88, our upper extreme. Q1 is 60, Q2 was 65.6, I think it was 5, and Q3 is 69.5. At a glance, a box and whisker plot conveys the median, the position of the middle half of the data, which is how big the box is. Q1 to Q3 includes half the data. The range it shows from the lowest to the highest, from the left whisker to the right whisker. And the skewness, how far the box and whiskers are off center. Example 5, construct a box and whisker plot for the weekly study time data in the stem and leaf display below. Okay, so from our stem and leaf plot here, we've got the values 12, 14, 15, 16, 17, 18. Continuing up, our highest value is 72. You can see that the 50% of the data there, Q2 is our median, 31.5. Q1 is 24. Q3 is 45. And you can see that the box is not directly in the middle. So we can see that the values are the middle of the data is lower than right in the middle. That's section 12.4, displays of data.